Good afternoon. My name is Luisa Fernanda. I am civil engineering student at the University of Lausanne. Today I will speak about an investigation of the mechanical and Puzolanics properties formed in limbus past with metacholine addition. By way of introduction, I talk about in order to understand the behavior of limbus mortars and to identify the influence of pozzolan. It is important to investigate the microstructure and properties of limb-based pods without any aggregates. In this work, 9 different sets of pods with addition of metacholine and brick dust were studied. The drawback related to the use of lime alone is a vendor, for example, slow setting and carbonation, high shrinkage, and low resistance have been overcome in recent decades by using Portland cement. The most important objectives of this investigation are: first, understand the behavior of lime mortars for proper modeling and design. Second, identify the influence of pozzolan by investigating the microstructure. 9 different sets of paste with addition of metacholine and brick power were studied. The study revealed that metacholine exhibit more stronger pozzolan activity than brick dust. Materials. The materials was used for the particle size distribution called metacholine brick powder. In this graphic, we can see classification curves of the individual materials. The blue line corresponds to metacholine, the black line corresponds to lime, and the red line corresponds to crucial break. Materials found in samples. The chemical composition of the materials used was studied with an EDX-RF analysis, a versatile X-ray sampling technique. In Table 1, we can see chemical composition of materials used. I would like to talk about samples, different characteristics. The pods were cast into prismatic molds with a dimension of 40, 116 millimeters and removed after 6 days. During casting, the parts were slightly compact using a shaking table so in order to remove the excessive high bubbles and voids. So curing was executed in the common laboratory condition at temperature of 20 degrees centigrade and relative humidity of 50%. It is noted that if an additional medication were applied, it could have resulted in the development of even large amount of hydration, production decays, pastes with higher metacholine content 30 on 40%. However, we preferred to use the same curing condition for all samples. This topic is very important because explain the Puzolanics activity was evaluated using the Chapelle test. This method is based on the reactivity of the test material with calcium oxide in water. The prepared mixture were kept at the temperature of 18.5 degrees centigrade for 16 hours. After that time, the mixture was filtered and the CaO content was determined by sucrose extraction and titration with chlorhydric acid solution. In the table 4, we can see Puzolanics activity of metacholine and crucial breaks. In here, we can see wave development, two different graphics. About the titration products can be detected from a measurement of wave development as they bind to water during development. The addition of metacholine in graphic blue results in a key significant reduction in weight loss early age. In different cases, result of CV and L post, this water retention was not observed in past containing cruise bricks, indication of weak puzzle and erection. Finally, we can say that the investigation of liposuction and past provide a valuable results and find the beside the presence of aggregates. The information contained in the paper can be for use in a modeling or design of limbus mortar that are nowadays used for repairs of cultural heritage. In addition, metacholine proved to the much more active puzzle and the brick duster which, in accordance with the puzzle activity, the result The Puzolanic reaction in the past containing metacooling was confirmed by the development of wave during hardening.